As we move into chapter 3 is all about solving two equations at once, or maybe three equations at once. We're going to combine 3-1 and 3-2. 3-1 uses tables and graphs. If anybody's interested to know how a table can help you solve, I'm more than happy to do that. You just get X and Y values until they're the same. But really, we're just going to focus on graphing. We're going to focus on two other things in 3-2. So we're going to focus on graphing, and then we're going to focus on substitution to solve equations and elimination. Okay, we're going to focus on those three things primarily today. So let's talk about how to solve a system. Now, a system means that you have two variables and two equations, or three variables and three equations. That's what a system is, and then you solve for all the variables. So part one, we're going to solve by graphing. The answer is where they meet. Now, the real way of saying that is saying the word intersect. Okay, where they meet or where they intersect. So let's do problem one. Step one, solve for y. So minus x to both sides. We should be really good at this from chapter 2. 2y equals negative x minus 8. Divide each side by 2. Remember, there's a negative 1 in front of the x. So we're going to divide everything by 2. You get y equals negative 1/2 x minus 4 when you divide 8 by 2. Next step, do the second equation. Add 3x. You have to have these in y equals, otherwise you can't graph using y equals mx plus b. 2y equals the positive 3x plus the 8. Divide everything by 2. They've been very nice on the problems they've given us. And the back number, like this 8/2, divides evenly. If it doesn't, graphing is a terrible way to solve. Let's graph the first equation. I'll use a purple marker, struggled there, to graph this equation. Go down on the y-axis 4 units. You should be very familiar with this. Descend 1 unit and go right 2 units. Go down and right, down and right. Now you can also go up and left. That would be fine if you run out of dots. There's actually nothing wrong with that. The more points you do, the easier graphing is going to be for you. Connect your lines. Again, I'm going to say that one more time. The more points you do, the easier graphing is going to be because you can see where they intersect. I'll do the other equation in blue. I'm going to go up 4 units. 1, 2, 3, 4. I would suggest using a pencil or a colored pencil in case you make a mistake. That way you can erase it. I will rise 3 units and go right 2 units because of 3/2. 1, 2, 3, 1, 2. You should do the same. I'm also going to, you can see I'm getting further away as I go this way, so I'm going to come back down so I can try to meet my purple line over here. So I'm going to go 1, 2, 3, left 2. 1, 2, 3, left 2. Do you see how I hit the mark? Like I hit the purple line right on? That's got to happen. Now, if you are choosing not to include a lot of dots, you might not know exactly where it crosses. Graphing can be very, very ambiguous, meaning like, well, where do they actually cross? So we really don't like to use graphing unless it's clean and clear. All right, this point right here is your answer. We actually have to put the answer 1, 2, 3, 4. So that's -4, comma 1, 2, -2. If you were to plug in -4, you would get out -2 in both of those original equations. So therefore, -4, -2 is the solution. The x comma y. Let's do that one more time. What is the solution of this system? Okay, take away x, -2y equals -x plus 4. Divide everything by -2. Remember, there's a -1 in front of your x. Y equals a positive 1/2 x. 4 divided by -2 makes a -2 for your y-intercept. Second equation. Take away 3x. y equals a negative 3x plus 5. I don't have to divide on this problem because there was nothing in front of y except a positive sign. Okay, I'll do the same color coding for you. Let's graph the first one in purple. Go down 2 for your y-intercept on the y-axis. Go up 1, right 2, up 1, right 2. Now, to complete this first line, I am going to go down 1, left 2, down 1, left 2. The more dots you do, the more accurate it will be. Connect, draw arrows to indicate it goes on forever. The second equation, I will graph in blue. If I'm going too fast, just pause your video and catch up with me. Go to your y-axis up to 5. 1, 2, 3, 4, for your y-intercept of 5. Then we're going to go down 3, don't forget, it's right 1. Down 3, right 1. 1, 2, 3, 1, 1, 2, 3, 1. Once you meet the other line, you have your answer. I'm going to finish by drawing my line, just so it looks pretty, but I do already have my answer. It's the spot where they intersect. And that spot is positive 2, negative 1. That's my x and my y value. If you were to plug in positive 2, I missed my negative sign. If you were to plug in negative 2 in each equation, you would get out negative 1 in each equation for y. That is the solution that works in both. Now, graphing doesn't always work because if you have a decimal answer, you have no idea where that decimal answer exists. But graphing does allow you to visually see some things. If you ever have two lines that intersect, it will have one solution. Okay? The one solution is where it crosses. We call that consistent and independent. You will be required to know these words on a test. So how can you tell if something is consistent and independent? Well, the slope is different. If you have different slopes, I should say slopes, I should have done plural there. If you have different slopes and they're different, they're going to cross. End of story. Okay? So it would have one solution. There would be an x, y solution. Okay. Now let's say that you get two lines and you graph them and they're the exact same line. In other words, the purple and the blue overlap each other. Well, if that happens, we call that consistent because it does have an answer, but we call it dependent because they depend on each other. They're exactly the same. We also say that's infinitely many solutions because it's like asking, when does one line touch the other line? Always. Now, in order for that to happen, the slope and the y-intercepts have to be the same. Okay, they have to be exactly the same. Now, if you graph and you get parallel lines, so maybe like your purple line was the top line, your blue line is the bottom line, if that happens, you're not going to have any solutions because they never meet. So if they're parallel, sorry, there's just an announcement I had to delete on over the speakers. If they are parallel, that means they're going to have no solution because they're never going to meet. In other words, they're never going to intersect. Sorry, I know my left hand's in the way. They're never going to intersect. We call that the keyword inconsistent because they never meet. They won't have an answer. Their answer is inconsistent. How do you know if they're parallel? The slope is the same, but the y-intercepts are going to be different. So that's how you could visually know from the equation. We are going to practice that somewhat quickly. Problem 4. In order to practice that, we are going to set each equation equal to y. So I'm going to move this guy over so I can actually write on my paper. So I'm not actually even going to graph them. There we go. I'll try to change yours before I print it. All right, so we're going to get 4y equals, add 2x to both sides. So 4y equals 2x plus 6. Divide everything by 4. And we get y equals 2 over 4 reduced is 1/2. 6 over 4 reduced is 3/2, or 1.5. Let's solve the other one. The only thing I have to do here is divide everything by 8 because x is already on the correct side. We're going to get y equals 4 over 8 is 1/2. Negative 12 over 8, on the other hand, is going to be negative 3 over 2. Now the big question is, do those equations match? Well, they're really close, right? But they don't match because one's positive and one's negative. So in other words, they have the same slope, which is going to make them parallel, but they have different y-intercepts. Okay? This makes parallel lines, which means there's no solution. In other words, it is inconsistent. Let's try that one more time. Down here, again, I'm going to move this on yours before I print it. What was it? X minus 1/3 y equals 1. Okay, the first one, add 3x to both sides. So add 3x. So we get y equals 3x plus 4. You don't need to divide by anything. This one, subtract x from both sides. So you get negative 1/3 y equals negative x plus 1. Last step, multiply the entire equation by a negative 3 to get rid of this. And you're dividing by negative 1/3, which means multiply by negative 3. So when you distribute that in, you get a positive y equals a positive 3x minus a 3. Again, we have the same slopes. Do you see how we have the same slopes? But again, we have different y-intercepts. So if you look at the chart above, that means we have parallel lines, which means the answer is no solution because they're never going to cross, which makes it, let's see, what do they ask? Does it have 0, 1, or infinitely many? It has 0 solutions.